experiencing. We are all aware of the many changes happening, technological and institutional and other types of changes. We have heard about it yesterday and today, about forecasts, about new products, new services. But my point is slightly different. I wanted to develop a conceptual framework where I could describe, interpret all these changes in a constructive way. So it's a very ambitious goal, as you can see. This is the last presentation before lunch. It's a very abstract lecture, so if you don't like abstract thinking, please leave the room now. I warn you, it's very abstract. Okay, what is the idea? The basic idea is very simple. I see what's happening to the electricity industry as a platformization of this industry. Strange word. This means that we are moving from a product, electricity as a product, to electricity as a platform. And this is a huge conceptual change, because it's not only about new technologies, it's about the way you see electricity in the broader context. So let's take a quick trip through this approach, talking about energy products and then about the electricity as a platform, very briefly, some opportunities and some challenges. We know that electricity traditionally is one energy product among other energy products. And this applies both to primary energy as to final energy and useful energy. We can talk about different energy products and each one of these different types of energy that we are considering. And we are used to competition between energy products. Let's think about heating. Here in the winter time, for instance, you want to heat this room. You can apply a heat pump, which is probably a very efficient solution. But you can also use electricity. You can produce the electricity locally with PV, for instance, or you can take the electricity from the grid. You can opt for a gas boiler. You can opt, if there is a gas pipeline, you can use a natural gas, or you would use LPG. You can go for coal, or for oil, or for biomass. If there is a district heating network, you can connect this home to the district heating network. So we have competition between products. We are used to that. That's the past. And we are used to look at these different products and to see how they are used in different sectors. Transport, industry, services, households, and so on. And we know that the energy product mix of each sector changes, is different. I mean, the energy product mix in households is different from industry, for sure, and it also changes over time. Okay, that was the past. That's what we are acquainted with. Now, this beautiful world of competition between different energy products, and to some extent you are experiencing it here in Israel with discovery of gas, and you see some nice competition between gas and other energy products. But this old picture, this traditional picture, is being challenged. And one thing that is happening is that these guys here, the users, the energy users, they are becoming, by millions around the world, also energy producers. This means basically electricity producers. But this is changing the landscape. And then we also know that, well, waste management, waste to energy became important in some parts of the world. It's not so much because of the energy, it's because of the waste management. If we want to avoid dumping waste, to some extent we need to burn it, to incinerate, and this produces energy. But also the heating and cooling, district heating and cooling, has an implication on electricity. Because if we are using cogeneration facilities, for instance, Obviously, the amount of heating and cooling that I'm producing has an implication on electricity production. And nowadays, we are talking about electric mobility. We want to go for not only for electric cars, but for electric trains, electric transportation. And all these different sectors that apparently have nothing to do with electricity, with the electricity industry, suddenly they all become interconnected with the electricity sector. And this gives to electricity a new role. It's more than just a product, it's becoming a platform. Platform where all these different sectors can interact in a very efficient way. And this is the picture of electricity as a platform, of the platformization of electricity. Electricity is not anymore one product, one energy product among many other energy products. Electricity becomes the central platform where we can trade energy, but we can trade, by trading energy, many other things. Because what we are doing when we are looking at electricity as this platform where we can manage together all the energy-related sectors, or almost all, is that we are also making decisions about greenhouse gas emissions. The goals of decarbonization that all our countries have around the world imply that there must be some trade-offs. And this is the best way to achieve these trade-offs, assuming that we have a proper carbon pricing and proper prices and a level playing field. We will talk about it later on. And so it's a very convenient way of bringing together all these energy-related sectors and coupling them in a technically and economically efficient way. Now, that's very nice. That's a nice picture. For sure, it's nice for electrical engineers, as most of you in this room, and as myself. But there are some buts, of course. This is a very complex machinery. This is like a gearbox. And if it's not perfectly designed and lubricated, it will not work. So we have to be very careful about the construction of this platform. It's not easy. It's not an easy task. But let's first talk about the positive things, about the opportunities. And I will mention only two. From the perspective of the industry, first of all, what we will see is the continuation and the acceleration of this trend that you can see here of the increasing penetration of electricity in total final energy consumption. You see, if we compare 73 and 2016, the whole world, during this period of time, the total final energy consumption increased by a factor of 2, while total final electricity consumption increased by a factor of 4, which means that electricity penetration increased from 9 to 19%, and by the way, in Israel it is 33%, if I'm not wrong. And this acceleration of electrification, of the penetration of electricity, will no doubt increase with time, which is very good news for the electricity companies all around the world, of course. But it's also good news for policymakers, because this, as I said before, enables us to manage decarbonization in a very nice way, bringing together, connecting all these sectors in terms of emissions allowed to each sector, and therefore also in terms of investments, because you see, these are all energy-related sectors. So we may decide, for instance, since we have the Paris Agreement, as you know, each country has an obligation to limit its greenhouse gas emissions. And this means that each country then has to divide the total national emissions by sectors, and is free to decide which sectors should contribute more to this national goal of decarbonization. Let's say that a country decides, for instance, to go for a strong and very fast decarbonization of the transport sector, electrifying the railroads, electrifying the road transport. This means less oil, less refineries, more electricity, decarbonization of electricity, which means more investments here, less investments there. So you see that this concept of electricity as the platform can make these trade-offs in terms of planning decisions and investment decisions from the perspective of policymakers, not only from the managers in the industry, much more rational. Okay, now let's go to the challenges. I don't want to spoil your lunch, I'm sorry, but I will be brief, and I will talk only about three main points that we should keep in mind while trying to build such a platform and moving from the product to the platform paradigm. Feasibility, reliability, and efficiency. These are the three key words, and each one would be enough for a full conference, but I will try to be very brief on each point, just giving you some key words. Let's start with feasibility. Feasibility means basically two things, or more things, but at least these two things. Design consistency and special attention to information. Design consistency is extremely important, and we know from experience, mainly from experience related to the liberalization processes in North America and in Europe and in other parts of the world, that a wrong design can lead to disaster. And we have seen some big, very big market failures. Maybe the biggest market failure, the most well-known example was California about 20 years ago, when the market, which was inconsistent by design, just collapsed, and it costed more than $60 billion to taxpayers. And why was it inconsistent by design? It was not because people were not aware of that. It was because this design was decided, although it was initially proposed by the regulator, it was decided and approved in the parliament. And the parliament tried to please all stakeholders. And therefore, the final design was completely inconsistent. It was only a matter of time until that market model would collapse. So we have to be very careful. We must learn from our mistakes in the liberalization process and try to avoid the same mistakes when platformizing the electricity industry. And so what I mean is that in terms of the architecture of the system, we must be aware that we are not dealing with a single sector, single level architecture as in the past, when electricity was a vertically integrated concept managed by a vertically integrated company. That was in the old times, but now we have decentralization on the one hand, and we have this coupling of many energy-related sectors. So that's a multiple sector, multiple level architecture, which is much, much more complex than the single sector, single level architecture of the past. In terms of complexity, this is totally different and very challenging. And then we have information. And nowadays, many people are excited about information and data mining and data analytics and all these things. I have nothing against it. On the contrary, I think that it is very nice that people get excited about the use of information and the application of new tools to the energy sector. But I believe that we should have a long-term perspective to really understand what's going on and what could be, should be the implications of this, of what's happening. And what's happening is a counter-revolution. Okay, so what does it mean? It means that for a long time, for about 1.5 century, the 19th century and most of the 20th, or part of the 20th century, we reasoned in terms of probabilities, average values. Okay? If you take, for instance, electricity network tariffs, this is all based on average values. When liberalization was introduced 25 years, 30 years ago, in some countries, there were no smart meters. So the only practical way to enable consumers, domestic consumers, or small consumers to switch from one supplier to the other was to use average values. Not individual values, but average values. Load profiles, as they were called. Okay? This was because we didn't have individual information. Now, this probabilistic revolution replaced a long period of several centuries where we were used, in terms of accounting, to have individual values for each transaction. And what the digitalization of the energy sector now enables is going back to those old days of individual transactions. So now, if we want to have a more efficient system of incentives for investments and for electricity consumers, we can modify our tariff system and we can get a much more efficient tariff structure. See, but you need to think about it in a more philosophical term and not just as playing with the new tools and waiting until something comes out. There is a clear philosophical change here, and this must be understood by industry and by regulators. Reliability is, of course, one of the most critical points. And there are two things here. One is coordination, and the other is the control flow problem. There are much more, but we don't have time for that. So, briefly, power engineers, they are used to coordination. Even in a vertically integrated monopoly, coordination is a daily job. You have to coordinate the different generators and the loads and the networks and substations and all these things from the technical perspective. Now, when you liberalize, you allow for some transactions in a market environment, we need to coordinate to some extent these economic transactions. So we need a market operation, we need a coordination at the economic level. And then we need to coordinate the market and the system operation. Because some of the market decisions may not be feasible with the existing infrastructure. So someone, the system operator, has to say, no, that economic coordination cannot take place. You have to change it in order to accommodate those transactions within the existing infrastructure. This coordination between the system and the market operations is a very complex one. There are different approaches that have been experienced in North America and in Europe and other parts of the world. If you go to North America, it's more a nodal-based approach. If you go to Europe, it's more a zonal-based approach. None of this system is perfect, but above all, none of this system is suitable for the future. Maybe they were good solutions for the liberalization under the conventional assumptions, but they are not good in the future. So we have to reinvent coordination. Coordination is just the first step, because coordination means that you have to choose winners and losers. When an economic transaction cannot take place, there will be winners and losers. And therefore, someone has to decide how to share the costs and the benefits that arise from the application of these coordination mechanisms. And this applies to the normal operation, the normal situation, but in some extreme cases, you cannot apply these rules, these sharing rules, if there is a big problem in the system and you don't want to just cut off some people, you need to apply some special solidarity rules. Okay, so as you see, coordination is a very complex thing. And to make things even more complex and to make even more of the audience to leave for lunch, I'm showing you now this, this nice picture. Now, EU stands for European Union, but you may replace this by any acronym for any supra-state organization. Okay. So basically what I mean is that we have these three different levels: the local, the national, and the supranational or superstate. We have network operators or some form of coordination at each level, and we also may have market operators at each one of this level. And then you have the market agents. Some of them participate only at these markets, but others may participate at both local and national markets. So it's much, much more complex than in the past. But this is the basic, the starting point for any coherent, consistent design of an electricity platform. And in particular, you have to define very carefully two things. We have to define the duties of each and the rights of each one of these entities here. If you don't define this precisely, you may have big trouble. And secondly, you must define very clearly the different rules for the interaction between these different actors. Because again, if you don't do that ex ante, there will be trouble afterwards. And it could end up in a disaster. For instance, this is what I call the critical square, how to introduce a new governance in order to enable some degree of decentralization and local electricity markets, while at the same time ensuring reliability of the whole system. So we need to be very careful and to define in very precise ways all these different interfaces. If you don't define the interfaces, if you don't define very carefully rights and duties of each one of these four, it will not work. Then we have the control flow problem, because digitalization brings many possibilities, but it also brings a big, big problem. A big, big challenge in terms of reliability. Because we can now access everything everywhere. I can access with my mobile phone all my devices at home, all my devices in my office. But also my supplier can access some of the devices. And also the network operator in some extreme cases. And tomorrow there will be aggregators who will also be able to access my devices. So if everybody is accessing my freezer at the same time, well, if this is multiplied by millions of freezers, that might be a problem. So we have to solve this problem. We cannot underestimate this problem. Of course, we can ignore this problem as long as there are only a dozen of crazy guys like me. We are playing with the freezer at home or with the printer in the office. But if this is amplified, multiplied by millions, then the system will not be stable. The system will collapse for sure. Anybody who has studied dynamics of nonlinear systems knows that perfectly. Okay, so we have to solve this problem. And then finally we have the efficiency issue. The efficiency concerns the creation of a level playing field, and in particular market structures and regulatory structures. So level playing field means that if you look at this picture that I showed you before, where electricity is at the center, like Louis XIV is the king, the son of the new energy system, of the new energy architecture, then if we want to have an efficient system, we must harmonize taxes, subsidies, incentives, and even technical rules. Otherwise, we may be introducing huge distortions. And the outcome, the economic outcome, will not be optimal, will not be a good one. It might be even perverse. Okay, then we have to think about the market structures. Because there is no such thing as the electricity market. Markets and electricity markets are social constructions, so they were created to serve some purposes, and we have to reinvent the electricity markets to serve our new goals, our future goals. But apart from that, let's think about the local level. Let's think, for instance, about electric mobility. How are we going to manage it? One idea may be to consider electric cars as any other type of consumer, industrial, commercial, whatever. So we don't distinguish between charging a battery in a car or supplying a freezer. So we don't need a non-electricity market. We consider everything as part of the local electricity market. But we may well decide to have a separate market for mobility, including electric mobility. And then this local mobility market must somehow interact with the local electricity market. So these are basic choices about the market structure, and this is not a trivial issue. Then, this is very important, especially for regulators. I'm not sure whether they are in the room, but whenever there is a big change, there is a level of inadequacy concerning the pre-existing infrastructure, and in particular the networks. This inadequacy may regard the topology of the network, the capacity, or the access to this infrastructure. Of course, there is always a physiological level of inadequacy over time. Everybody who is familiar with network planning or electricity planning knows that there is always a trade-off between new investments and adequacy of the infrastructure. There is always a compromise there. And so there is a pricing for inadequacy and an acceptance level for inadequacy. But this is the physiological level of inadequacy. What happens when there is a big change, like decentralization or digitalization that we are observing nowadays, is that very quickly the degree of inadequacy between the existing infrastructure, the existing networks, and what we are supposed to do becomes increasingly large. And at a certain stage, regulation must act and must bring new incentives to modify the existing infrastructure in order to make it adequate to the new goals. It will take some time, it will have some costs, it has to be done, to bring the level of inadequacy to acceptable levels again. And this is the transition. This requires a new type of regulation. And it's not obvious that regulators are always aware of this necessity. So we need a rational approach to regulatory change. First, this regulation must ensure compliance between the electricity system and the public policies. It must be fair and efficient. So I conclude, electricity is not just an old product, it's also a platform, a new platform. Electricity as a platform offers many new opportunities, but it requires strong efforts in terms of harmonization, design, and re-regulation. Thank you very much.